Hello and welcome to this quick video about finding tangents to curves for IGCSE. There are two different ways that we need to be able to do this: by estimating, which will allow us to draw graphs to find rough tangents to graphs that have got curves, and by differentiation, which is a much more precise way of doing it, and hopefully you'll find much easier as well. So method one, we need to draw a straight line at the point that they're asking us to find the tangent at. Now, I've already got my line sorted out, but you'll need to move your ruler around so you get it so it's just touching at one point. They've asked us to find x equals 0, and you can see that on my red line here, it's just touching the line as little as possible. After this, it's just a case of finding the gradient of the line. So remember, we need to know two different things. We need to know how far up or down it's gone, and we'll need to know how far along we've gone. So if I look at this line here, starting from, we might as well go for 0. It's gone a long 1, and it's gone down 4. Now when you're choosing your points, make sure you pick points that are easy to identify, so that where your line is crossing lines on the graph paper. So it's now simply difference in y, so difference in up and down, divided by difference in x, so difference in how far along it's gone. So the gradient here is -4. So key steps to go through: draw a line so it's just touching the curve. That's probably the most tricky part. Identify places where your line crosses the graph paper, how far along we've gone, and how far up or down we've gone. Difference in x, so difference in along, divided by difference in y. Difference in x, difference in y. Okay, so let's see if we get the same answer using differentiation. Now the rules for differentiation are very, very easy. You'll get it very quickly. Now we've got y equals 2x to the power 3 plus 2x squared minus 4x. To find the differentiation, the differential, dy dx, what I'm going to do is get my index and multiply it by any number that's in front of it. So here I'm going to do 3 times 2 is 6. Leave the x as an x, and going back to the index again, we take away 1. So that's going to be 6x to the power 2, 6x squared. So step 1, multiply power by the number in front, or the coefficient, and then step 2, take 1 from the power. And it's just going to be the same idea every time. So here, my power is now a 2, so I'm going to do 2 times 2 is 4, x to the power 1. And obviously x to the power 1 is just the same as x, but you can put a 1 in there if it helps you. Now on this one there's no power, which means there's a power of 1. So I'm going to do 1 times -4 is -4, and then it would be x to the 0, but x to the 0 is just equal to 1. So we could tidy it all up, 6x squared plus 4x minus 4. So that's what the differential is. Dy dx is 6x squared plus 4x minus 4. Now the question is asking me to find the gradient when x equals 0. So all we have to now do is substitute x equals 0 into this equation. So dy dx equals 6 times 0 squared plus 4 times 0 minus 4, which is 0 plus 0 minus 4, which is minus 4, which is very convenient as it's what we found on the previous slide. We'll just have one more go at that, make sure that we can remember what to do. So we're going to find the gradient of y equals 5x to the power 3 plus 4x squared minus 7x plus 6 when x equals 1. And they haven't shown us a nice little graph this time. So we're going to need to differentiate first. So dy by dx, so we get our power and multiply it by the coefficient. So that's going to start off with a 15 because 3 times 5 is 15, and then subtract 1 from the power, so that becomes 15x squared. Look at the next power. The next power is a 2. We bring it down and multiply by the coefficient. 2 times 4 is 8, so that's 8x minus 7 because 1 times 7 is 7. And then here we've got a plus 6. Now plus 6 is the same as plus 6x to the power 0. 0 times 6 is 0, so whenever you've just got a number on its own like that, it just disappears. We don't need to do anything with it because we're effectively multiplying by 0. So the differential is 15x squared, dy dx is 15x squared plus 8x minus 7. So all we now need to do is substitute x equals 1 into that. So when x equals 1, dy by dx equals 15 times 1 squared plus 8 times 1 minus 7, which is 16. So the gradient of that curve when x equals 1 is 16. And obviously if you had a picture, you could have used method 1 as well. Thanks very much.